Welcome to the Maritime Executives podcast series, In the Know. I'm Tony Munoz, Editor-in-Chief. Our Executive Corner podcast will provide conversations with top executives concerning events and issues that are shaping our industry today. We will also bring you up to speed with the latest news and editorials covered by the Maritime Executive. Maritime Executives, welcome. Today we have Chris Landsea. He is the Chief Tropical Analysis Analyst and Forecast Branch Manager for the Hurricane Center. Chris, did I get that right? Is that close enough? Close
Yes,
enough. Okay.
that is close enough, Tony.
That's great. The branch generates wind and wave forecasts for the Caribbean, the Gulf of Mexico, the tropical North Atlantic Ocean, and the tropical northeastern Pacific. Welcome today, and after the events of Helena, we are very thankful that you're here, and you and I had spoke before previously. We had talked about the lack of hurricanes in the pattern. Now, with Helena coming through, now we can address some other issues about the power of these storms. And so I'd like to let you talk about the events, recent events, and take us from there.
Well, thanks, Tony. I appreciate the opportunity to be here today and get a chance to talk about what we do for the mariners every day,
Excellent.
not just during hurricane season. Certainly, we've had horrific impact with Hurricane Helene in North Carolina, South Carolina, and the Florida Big Bend area. For those that are living in South Florida, we escaped without much impact. Season's not over, unfortunately, and so we still have another month where we can have strong hurricanes impact, and the season goes to the end of November officially. So even though we're past the peak, it's an active area period right now, and we still have to be cautious and monitoring what's going on. So I appreciate the opportunity today to talk to you about our marine products and services that we do here at the National Hurricane Center, which is in addition to the more well-known hurricane forecasts that are done directly. And just to put it into context, our mission statement, to paraphrase what it says here, is to provide wind and wave analysis and predictions and issue warnings for mariners over the tropical and subtropical Atlantic, Caribbean, Gulf of Mexico, and the East Pacific, so that mariners can protect themselves and protect their property as well. And we are federal employees, and so TAFB is the largest part of the National Hurricane Center. TAFB, again, is the Tropical Analysis and Forecast Branch. We have 16 full-time forecasters. National Hurricane Center is one of 9 national centers for environmental prediction. We're all part of the National Weather Service. And the National Weather Service is the largest part of NOAA, National Oceanic and Atmospheric Administration, and we're all wrapped into Department of Commerce. And you might say, well, that's a little odd. Why is Weather Service and NOAA in commerce? But if you blow up their logo, you can actually see on there a sailing ship and a lighthouse, and it speaks to the importance of weather forecasting for our economy. And in particular, we'll talk about ports and how we interact with the Coast Guard for those really big decisions for ports that they have to do. So that's kind of why we're in Department of Commerce, is we're doing science-based service organization, and we're helping the U.S. and individuals making good choice when weather gets bad. So when we're doing our forecasts, it's not just for the National Weather Service, but it's also part of the International Maritime Organization. So the IMO is an agency within the United Nations. And the IMO was started after the sinking of the Titanic over 100 years ago, when it was realized that ships anywhere over the global oceans need forecasts, need free predictions and warning services to stay safe. So you can see these colors showing that every square inch of the global ocean, there's a country responsible for making those forecasts. And in particular, the United States has responsibility for the Northeast Pacific and the North Atlantic. Kind of providing a little more detail on that, specifically whom within the Weather Service depends geography. And so geographically, the folks within 60 miles of the coast, the coastal waters, that's provided by the local weather forecast offices. So that little pink ribbon right along the U.S. coast. And so for the high latitudes, that's done by the Ocean Prediction Center, both in the Pacific and the Atlantic. The Central Pacific, by those lucky enough to work in Honolulu, it's done by the Honolulu Forecast Office. And the green represents our waters. So the tropical Atlantic, subtropical Atlantic, the Caribbean Sea, the Gulf of Mexico, as well as East Pacific. So we have 10 million square nautical miles. So it's a big chunk of ocean that we're monitoring, not just hurricane season, but all year round. And we do want to try to make sure it's seamless for the mariner, for products. It shouldn't matter if you're just south of Jacksonville and in our waters or just north of it in Ocean Prediction Center's waters, should be able to get the same products and services. We're not quite there, but we're moving toward that as best we can. So I did want to talk about the meteorological hazards a little bit. And so we really have two seasons down here in the tropics. We have the winter time where we have cold fronts and extratropical lows. And these colored areas indicate where we get either infrequent, which is in yellow, or more frequent, which is in orange and red, gales or even storm events. And so you can see in the Gulf of Mexico, very common near Veracruz and Tampico, as you get a cold front coming across the Gulf, and those winds bank up against the Sierra Madre Orientales. And so that causes enhanced winds in that part of the Gulf. We can also have very common gales in winter and spring just north of Colombia, as the Bermuda High is interacting with the Colombian Low and the high topography of North Colombia. Then it's very common just east of Florida as well, with winter cold fronts and extratropical cyclones. And so you can see a lot of this is tied to the topography. So it's not just the meteorology, but it's the surrounding mountains that can play a role in dictating winds over the water. When we get to June, things switch. And instead of cold fronts and extratropical cyclones, we're looking at tropical storms and hurricanes, obviously. And even though it's a 6-month season, it really ramps up. So that the 3 months of August, September, and October, you get 90% of your major hurricanes just in those 3 months. And you can see in August, September, the area of occurrence spreads east and north. And by the time you're getting to October, you can still have very strong hurricanes, but you're tending not to have much activity in the eastern part of the Atlantic. And so you have to be concerned about it all 6 months. But again, the big 3 months are August, September, and October. So switching a little bit to our tools. And so we want to talk about how we make forecasts. And we start with the measurements or the observations. And over the Atlantic, Caribbean, and Gulf, we're fortunate. We've got a mix of ships providing their observations, which is really critical because there's hundreds and hundreds of ships out there. And so the more we can get from you all, the better we can make the predictions. There's also moored buoys maintained by the National Data Buoy Center in Mississippi. More recently, we've gotten so far drifting buoys that gives us waves over the oceans from a beach ball sized instrument. Supplementing that, we have remote sensed information that's from space. And so these colored wind barbs it's called a scatterometer. It's a radar in space where it's not even a U.S. instrument. It's the European Space Agency. And we're fortunate to get those wind speed and directions. And then the colored numbers are an altimeter. And so it's another radar in space that measures wave heights that are accurate to the nearest foot. And so we get a nice mix of both local measurements, what we call in situ, as well as remote sensed info. We supplement that with the imagery. And so these observations that are taken by observatories in space, called geostationary satellites, give us continuous pictures as well as data that gets into the computer models of what's going on. And since we're tropical meteorologists, we're really focused on cloud features because clouds and deep thunderstorms are the predecessors to tropical storms and hurricanes forming. So these platforms that are launched by NASA, that cost about $1 billion each, paid for by your tax dollars, once they're up and ready to go, then they're maintained by NOAA at a facility in Suitland, Maryland. And they're really critical for us. without this imagery, Tony, we would be blind to what's going on out there for forming tropical storms and hurricanes. And then another part of our tool set are the computer models. Because of the domain we do of that 10 million square nautical miles, we really focus on global weather models and wave models rather than local ones. And so we actually have a database of winds that we maintain to do a 6-day prediction in time. And we populate that with both, for example, winds from the global forecast system that the National Weather Service runs, as well as the European Center for Medium Range Weather Forecasting, so the ECMWF. So we have wave models from those two agencies as well. We do run one model locally called the Near Shore Wave Prediction System, and that gives us consistent wind waves as well as swell that match the wind forcing. Because you really do need a consistent set of predictions for the mariners out over the open ocean. This really comes to fore during the hurricane season, because we need to maintain consistency with what our colleagues across the hall are doing at the Hurricane Specialist Unit. So they're the ones that do the 5-day cone forecast. And so this forecast for Hurricane Ida a couple of years ago is a nice illustration of how we work together. So they'll do the cone forecast an hour before it goes public. That's sent internally to everybody in the weather services. So the coastal offices that do that 60-mile strip along the coast, as well as our office in the Ocean Prediction Center. So we're filling in the details. We're working really hard 1 hour before that goes public to make a wind and wave and marine warnings that are consistent with this prediction. So for a 1-day forecast, shown about that star there, we're filling in the winds over the entire Gulf of Mexico and waves over the whole Gulf. So this particular system, Category 4 Hurricane Ida, we had waves that reached up to 35 to 40 feet just south of Louisiana. And that's important for that consistency of message at the local forecast office, for our marine branch and the hurricane specialists, because you wouldn't want them saying it's going to be a Category 4 and we're only saying 5-foot seas. That wouldn't make any sense. So fortunately, we have some great tools to build in that consistency of message to the mariners. And finally, we're doing this all on one workstation. I'm actually out here in operations today helping to do the unified surface analysis, a weather map of what's going on. And we do everything within a framework called the Advanced Weather Interactive Processing System. I can't even say it, but it allows us to look at everything: the satellite imagery, the radar data, the scatterometer from space, the ship observations, the buoys, the computer models, and issue all of our products, the text products and the graphics and the grids themselves. So it's really efficient most of the time to be able to do that all in one. So some of our products, I'm not going to go into detail on those. We do have 2 webinars that we host, one in November and one in June, to talk about in detail our products. So I'm going to just do a little bit of a highlight today. But we do forecasts for mariners, both in the traditional text products, including the Global Marine Distress and Safety System that is mandated by the IMO for reception on large vessels, and the graphics, which are both radio fax graphics as well as web-based, and the grids themselves, so you can actually view our forecast directly. And so we're going to continue to provide the products in these variety of formats so that folks over the open ocean can take appropriate actions. So I'll highlight one of those. One of this is the offshore zone forecasts that we issue. So each one of these little shapes has a distinct 5-day forecast we're providing in a text product format, and it includes any warnings that are in place. So let's just take a quick look at what is being done this morning here. And this is being issued by Jorge Aguirre. Right behind me is doing the marine forecast for the Atlantic, Caribbean, Gulf. So for example, if you're going to be going over to the Flower Garden Bank Marine Sanctuary that NOAA runs south of Louisiana over the open ocean, it's pretty good for going out there. You know, winds are only 10 to 15 knots and seas 4 foot or less. So pretty good conditions right now. That could change in a few days as we're looking at some some potential impacts from a tropical system that could occur by the weekend there. So this is an example of where you can get a real quick forecast of both the winds and waves and any warnings that are in place. So another example is some of the surface progs for some of our graphics here. And this is a forecaster-derived representation of the features that are of interest, whether it's tropical storms, and then during the wintertime, whether it's frontal boundaries. So you get a bit of about the why of the forecast, not just the what. And so that's important for mariners in their decision-making of, not only what's going on for winds and waves, but why are they occurring? And we provide these twice a day, and it goes for days 1, days 2, and days 3. So we can take a look at what the forecasters on the midnight shift did last night. And you can see here, Hurricane Kirk is anticipated to be in 2.5 days, a Category 3 hurricane, fortunately staying out over the open ocean and even away from most of the main shipping lines. And behind it is another system that could become a tropical cyclone that we're monitoring closely as well. So this is a nice example of a fairly busy period, but again, not too much right near the United States or even in our offshore zones. So I did want to say a little bit specifically about hurricane avoidance. In the past, mariners were taught to use the 1, 2, 3 rule, where one had to plot up on a map the forecast positions for the first 3 days, know what the forecast size is, that's the 34 knot wind radii, and then draw a circle 100, 200, and 300 mile radius around the system. And then you have this cone to avoid. It was pretty complicated. And fortunately, we're saying you don't have to do that. We're going to do the math for you. And so we have a product that provides the tropical cyclone danger information called a danger graphic. And so this provides hazard areas to avoid. And so I'm going to go into this a little more detail here because it's real important to understand it. So for example, in fact, we'll take a look at what's going on now because we do have the active tropical storm Kirk. And you can see there's 2 areas. The dark hatching is at least a 50% chance of tropical storm winds, and the light hatching is a 5% chance of tropical storm winds. Again, that's 34 knots or higher. And in this case, it's a 3-day prediction of what's going to go on. So this is useful for mariners that are going to want to avoid those. And it takes into account the risk avoidance too. So if you just want to know what's the most likely location for those winds, then you're using the dark hatching because that's at least 50%. But let's say that you've got a cargo, unlike a cargo ship, like a cruise liner, where you want to make darn sure you avoid those tropical storm winds, because unlike a cargo ship or an oil tanker, the cargo on a cruise ship tweet, and you don't want them tweeting bad things about your cruise liner. So you'll probably want to be very risk averse and use that 5% chance of tropical storm winds because you want to make darn sure you're staying out of those high winds and large seas. So one thing that we're trying to do is make it easier to access our information more directly. And so one way we're doing that was with what's called the Marine Composite page, where you can take a look at images right from our gridded database of winds and waves and warnings. And this is an example of a couple of years ago from Hurricane Earl, but we can go directly to our website. And again, to get our website, it's hurricanes.gov/marine. So it's pretty straightforward. But let's take a look at what has been forecast. Here are the wind barbs. So it's a wind 10 meters above the ocean, roughly 35 feet. And we can put on the wave heights on there, as well as the forecaster-derived features. And so this was the analysis that I just made a few minutes ago on our Surface desk for 12Z. And the colors represent the significant wave heights. So anything yellow is at least 12 foot or 4 meters. So that's pretty nasty out there with Hurricane Kirk, and it's pretty large. So we can go forward in time to tomorrow morning, and you can see Hurricane Kirk is going to get even larger in size and stronger, and the blue reaching up to 35 foot or more. Forecast extending through Friday morning as it's starting to move poleward, and then all the way through Saturday morning, showing the conditions as the system's getting close to our 30 north border. So again, a real quick and easy way to see the official forecast from the National Weather Service that's consistent with the cone graphic that the hurricane specialists are providing. So that's a real quickie about our products there. I did want to talk about our services that we provide. One of the big issues with the National Weather Service is impact-based decision support services, how we help core governmental partners make the tough calls. And unfortunately, there's been some issues in the past with mariners getting in trouble and then asking the U.S. Coast Guard for help. The most infamous of which was the El Faro, which was a U.S. flagged cargo ship taking cars every week from Jacksonville down to Puerto Rico, and then goods back from Puerto Rico to Jacksonville. And unfortunately, the captain took this vessel, 1,100 foot long cargo ship, right into the eye wall of Hurricane Joaquin. And they got a lot of water, and they called Mayday for the Coast Guard, and 20 minutes later, they sank to the ocean floor with all 33 souls. And it was a really horrific event that was completely avoidable. And while the forecasts weren't perfect, and they never are, there's always errors in the predictions of hurricanes and winds and waves. The key for this disaster was decision making, both by the captain and the company. And so what happened was the captain kind of anchored his decision making on the first forecast and decided to go directly from Jacksonville to San Juan, whereas in retrospect, it would have been much safer to use the old Bahamas Channel between the Bahamas and Cuba. And so fortunately, after this, there's been steps taken by the industry as well as the Coast Guard to try to avoid disasters like this going forward. But it still is incumbent upon the mariners, both the captain, the crew, and the shoreside operations, to be paying attention and changing plans if a hurricane does arise. And we can actually see that. And so with the marinetraffic.com website, we can see where the ships are. And so this is the next few slides are an example of really good decision making by 95% of the vessels out there. And these are color coded by types, where the red are oil tankers, the orange are fishing boats, the green are cargo ships, the blue are cruise liners, the purple are giant personal yachts, and the light blue are tugs and special craft working the oil platforms. And as Hurricane Delta emerged off the Yucatan coast and heading toward Louisiana, you can see vessels getting out of the way, not only where the hurricane is, but where the hurricane was going toward Louisiana. And so it's really gratifying for us as forecasters to see mariners doing the right thing. We're not sure if they're using our forecast or private sector or ship routing company, but regardless, they're doing the right thing. And after this particular hurricane came ashore, then NOAA and U.S. Army Corps of Engineers and the local officials and the Coast Guard are checking the ports, checking the harbors, making sure that the aids to navigation are in place and there's nothing blocking the ports to reopen them again, because that's a big, as we talked about, it's a big economic engine for the U.S. is the ports and getting them back open. So I've mentioned the Coast Guard a couple times. So I did want to mention a little bit about our special relationship with them. Unlike the Navy or unlike the U.S. Air Force or even the Marine Corps, the U.S. Coast Guard has exactly 0 forecasters. So by design, every 10 years, we re-sign a memorandum of agreement between the Coast Guard and the National Weather Service, where we provide them forecasts and briefing support in order for them to do their life-saving mission. And so that's something we've embraced here at the Hurricane Center, where we work very closely with the U.S. Coast Guard at the district level, whether it's District 7 in Miami, District 8 in New Orleans, District 11 in California, or even District 14 sometimes in Honolulu. So one example is spot weather forecasts. So it could be that there's a vessel in distress It could be an aircraft that's ditched over the open ocean. It could be for law enforcement activities where they're chasing the bad guys, or they're trying to help out a vessel full with migrants that are in really perilous condition. Whatever the incident, we say, yes, sir, yes, ma'am, here's the forecast, and we get it to them within 20, 30 minutes. And so this is helpful for them in order for them to do their mission, which always puts them at risk over the open ocean with winds and waves. Another aspect of decision support is for tropical storms and hurricanes. When a hurricane is getting ready to threaten the United States, a core responsibility of the Coast Guard is which ports to restrict and which ones to close in advance of the hurricane. And that's a really tough decision that the captain of the port has to do. I wouldn't want that job. But we're providing the meteorology for them to make informed decisions in order to, make proper choices when a hurricane's coming. Because you don't want the port to be open and a big hurricane come ashore. But on the flip side, you don't want to close ports unnecessarily if they're not at risk of winds and waves and storm surge. So last year we did 26 live briefings. It's been a busy year for the U.S. We've already done over 50 briefings this year. And the quote down there from Captain Hortensio with his appreciation at District 7 for what we do to support their mission. Last couple things, we do try to reach out to the marine community, as like we're doing today on this opportunity to discuss what's going on. We have a weather hazards workshop that we host every year where we bring in reps from the cruise lines, cargo ships, oil companies, fisheries, Coast Guard, Navy, so that we can get a chance to talk to them about what do they need to stay safe over the open ocean. What are we missing that we should be providing? We're also trying to do more on social media. So an example, anytime that we do a warning, we tweet it out, and it goes out within 10 seconds over X. We also do a twice a week tropical Atlantic marine weather briefing, where we're providing a 3 to 5 minute overview of what's going to happen over the Atlantic, Caribbean, and Gulf of Mexico for the next 5 days. And so if that's something you want to do, let me know. We can get you signed up to receive that there. And then finally, we're getting our forecasters aboard vessels, because what we've noticed is that when we're doing a prediction, say, of 6-foot seas or 12-foot seas, it's pretty abstract. And only one of our forecasters has had a lot of ship time. And so we're getting our forecasters aboard both NOAA vessels and Coast Guard vessels in order for us as meteorologists to better appreciate some of the difficulties you can experience while being over the open ocean. So just to wrap up, I do want to acknowledge how rapidly communications are changing over the open ocean. For decades, the Coast Guard has been very helpful by maintaining transmitters for voice broadcasts, for text broadcasts, and graphical broadcasts using radio technology. Yeah, but that's changing. It's changing really, really fast. And so because of Starlink in particular, that SpaceX is launching all these mini satellites, everyone over the open ocean is getting relatively cheap, reliable, high-speed internet anywhere over the global oceans. And so when we're talking to mariners that get that, they're like, yeah, we go to windy.com. And I get it. Windy's got some beautiful graphics of winds and waves, but it's not the official forecast. And so our holy grail is to get our gridded information, get our polygons of no-go zones into the electronic charting and navigation system. So the ECDIS aboard all large vessels, and it's going to be this S100 based information. And so that way they'll be able to overlay directly on the navigation software our winds and waves as well as warnings. And this is going to be voluntary starting very shortly and then mandatory by 2029. So that's where we're hoping to go, where we can provide official information right to the navigation software for captain and crew. So on behalf of everybody here at the Tropical Analysis and Forecast Branch, our 16 marine forecasters, we're happy to serve and helping you keep you safe. Again, our website is simply hurricanes.gov.marine. And if you are over the open ocean and you've got a question about the forecast, we don't do ship routing per se, but we're happy to answer questions. So there's our phone number, 305-229-4424. So, Tony, I hope that's been a helpful overview about what we do. Was there anything you missed that I missed or that you want me to cover in a little more detail?
So you had mentioned that the hurricanes are going to be less than volume wise, but bigger. Is that still the analysis?
Right. So we haven't had a huge number of tropical storms and hurricanes this
Right,
year, but the ones we've had so many that have impacted the United States. We've had four U.S. landfalling hurricanes, and the average is only about two per year. So even though overall it's not been crazy busy like we thought it would be,
right.
the impacts for the U.S. have been there. And of course, with Hurricane Helene, not only the impact for the Big Bend area of Florida, which is fairly unpopulated, there was the inland impact of the massive rain that occurred in the Carolinas, and they're still dealing with the aftermath of that now.
Yeah, for sure. Well, I want to thank you very much for taking your time and helping us. Mariners are a unique breed, especially the boaters that go out there. They go to Abaco and go to all these different places on their yachts and speed across the Atlantic. But we also have the trade lane of cargo ships that come in and out. And, the Alfara was a tragic situation using older data versus modern technologies. So, but no, we thank you for your time and appreciate it. And explain to mariners how they can get up-to-date information again, please.
Sure. It's to get the latest, you just go to hurricanes.gov/marine. And so that'll take you right to our marine forecast there. And it's critical because sometimes
Yes,
conditions
it
can
is.
change fairly quickly during hurricane season.
Yeah.
But we do our best to provide the predictions that we can that are consistent with our colleagues at the Hurricane Specialist Unit. And we'll want to wish everyone to stay safe the rest of the hurricane season and during the winter time.
Well, thanks for taking your time, especially after such an event. We appreciate it.
You're welcome, Tony. Have a great day.
You too. Bye.